for example. Okay, so we are going to start off with simplifying fractions. So can you raise your hand if you have worked with simplifying fractions? Like use the raise hand icon. Okay. I see, yeah. Only a few of you, like 6 of you are raising your hand. So yeah. Okay, so this is probably a bit new to some of you. Or if you don't know it at all, that is also that is good because you're going to be learning, right? So okay. So we are going to talk about different ways with which you could simplify fractions. So there is prime factorization. So do you all know how to do prime factorization? If so, react with the raised hand. Okay. So wait, okay. Wait, can everyone hear me? Just unmuting. Okay.
Yeah, you can.
Yeah, okay. Um okay. So okay. So I only see like a couple of you have worked with prime factorization before, so we're gonna just um uh it's like start off with a little bit of prime factorization. So okay, do you all know what prime numbers are? Again, just raise your hand. Or yeah, use a thumbs up. Okay, so I see quite a lot of you are not reacting. So I don't know if that means that you don't know it or you just are like not able to raise your hand. Okay, but okay, so most of you do know what a prime number is. So I'm going to start off with that. So a prime number is a number that is only divisible by 1 and itself. So for example, we have the number 5, right? If we look at all the numbers that divide 5 evenly, right, then that's 1, right? And then 2 won't divide it because it's not even. 3 won't divide it because 3 times 1 is 3, and 3 times 2 is 6, and 5 is neither of those. And then 4 won't divide it since 4 times 1 is 4, 4 times 2 is 8, 5 is neither of those. And then 5 is the only other factor of this. So that would mean that 5, okay, so that would mean that 5 is is a prime number. So using this, we know that there are a specific set of prime numbers and they're never going to change, right? Because the factors of a number will not change. So the prime numbers would be like the smallest ones would be 2, 3, 5, 7, 11, 13, 17, 19, and so on, right? So we could just look at what numbers divide these numbers, and then we can see that knowing that, okay, we can look at the factors of a number and tell if it's prime, right? So that would mean so what we're going to move on to next is what prime factorization is. So prime factorization is when we look at the so we looked at the factors of each of these numbers and we saw that there are only 2. So we look at the factors of 28. So how would we break down 28? Like what numbers do we know multiply to 28? And you could type your answer in the chat if you want, you can unmute. But if you raise your hand, I probably won't be able to just let call in.
4 and 8.
Yeah,
No,
or no, not 4 and 8. Sorry, can you repeat what you said? Okay, so I see someone saying 4 and 7. Yeah, 4 and 7 are definitely numbers that divide it. However, if we look at 4 and 7, only one of these is prime, and that is 7, right? So what we want to do is we want to find what prime numbers divide 4. So what are the factors of 4? Like what numbers would multiply to 4? Yeah, 2 and 2 would multiply to 4. So that would mean that we can express 28 as 2 times 2 times 7. Sorry, I'm a bit slow at writing this down. Also, by the way, if you do not have a question right now, you can just lower your hand. I know I asked you all earlier, like, if you knew certain topics, but right now I don't need to know. Like, you don't need to raise your hand. Okay. So we can re-express 28. So that means we can just write it out as 2 times 2 times 7. And now we're going to do the same thing for 16. So I actually want you all to private message me because that just because like other people might get it wrong, other people might get it right. You don't want to impact other people's answers, right? So okay, so what is the prime factorization for 16? So I want you all to try to do it on your own. Okay, the question was, what is the prime factorization of 16? Okay, so I am seeing a few answers, right? So you probably might not know what exponents are right now. So I'm just gonna stick to not using exponents, right? So 16 is divisible by so you might know that 16 is 8 times 2, right? 2 is a prime number. 8 we can divide into 4 and 2, and we know again 2 is a prime number, but 4 isn't. So okay, so that would mean that and then we look at the factors of 4. So 2 and 2, right? So we count 1, 2, 3, 4. 2's are being multiplied together. So 2 times 2 times 2 times 2. Right? So this is how we would express okay, if sorry. So yeah. Okay, so it would be 2 times 2 times 2 times 2 for 16, and 2 times 2 times 7 for 28. So what we want to do now is we want to see which of the prime factors are similar and just cross them out. So we have one pair of 2 right in the numerator and denominator, so they would divide out. So think about like if we were looking at 2 divided by 2, if we were looking at 2 divided by 2, that is equal to 1 because we can divide both the top number and the bottom number by 2. So we do that for all the shared numbers in the top and bottom, and we get 7 over 2 times 2. So what is 2 times 2?
Four.
Yeah, it is 4, right? So we would get 7 over 4. So this okay. So if you all have any questions, please ask me right now, because especially if this is a new topic to you completely, then it helps just to know, right? What I need to clarify on, what me and Ruth would need to clarify. So
Okay.
okay. So if you have any questions, feel free to raise your hand or put it in the chat. You can private message either me or so okay, Ruth.
Okay, so the second method to simplifying fractions is to find the greatest common factor. And so right here we have 54 and 30. And so to find the greatest common factor, what you can do is you can split each number into all of its factors. For example, 54 could be split into 6 and 9, and 30 can be split into 6 and 5. And so between the two, there's a common factor of 6. And so it's similarly to the last one, since there's a common factor in the numerator and the denominator, you can cancel them out. And so the simplified fraction would be 9 over 5. And you know that you're done because 9 and 5 don't have any common factors.
Yeah, and it doesn't even have to be the greatest common factor we start out with. We can just start out with the factor we know they share. Like 54 and 30, we can tell that they're both divisible by 2 since they're even. So we can start off by dividing both of them by 2, and then we can see they're divisible by 3, that 27 and 15 are both divisible by 3, and then we divide that, and then we would still get the same answer. So okay, so some practice. What would 16 over 36 be? So just private message. Here, yeah, please private message. And also don't argue in the chat, you know. This is the first class. You don't need like yeah, just don't. Okay, someone is raising their hand. Ready?
So do I like private chat do the answer, or do we raise our hand to tell you the answer?
Private chat, just to tell us the answer, because if you say it out loud, then right, it might, like, other people might still be doing it and stuff. So yeah,
Okay.
it's yeah.
Okay.
Again, everyone, please private message your answers. But yes, you all are correct. It is 4 over 9. So you could just do like, you can tell 16 is equal to 2 times 2 times 2 times 2 times 2, right? So, yeah. And then 36 is equal to 2 times 2 times 3 times 3, right? Since 36 is equal to 6 squared and 6 is equal to 2 times 3. And then we can cancel out these, the shared factors, right? So 2 times 2 is shared by both 16 and 36. And also, by the way, if you think that it is hard, don't worry. Like, when you do more practice problems, it will become much easier to do, right? So yeah. So 2 times 2 and 3 times 3, right? So we are able to get this is equal to 4 over 9 when we simplify. So good job.
So the next question is 51 over 34.
Yeah.
And you
this
can
time,
private
yeah.
message your
Yeah.
answers.
Yeah, please private message your answers to your this. Remember, you should be private messaging Ruth, not me, for this one.
Who do we send our messages to?
Send it to Ruth for this one, please.
Who?
Ruth, you should.
Me.
Yeah.
Okay, so a lot of people are saying 1 and 17 over 34 because this is a mixed number technically. But I want you to simplify it so that because 17 over 34 can be simplified. Okay, so a lot of people are getting the right answer, and it is 3 over 2, or you can say 1 and 1/2. And so for this one, what you would do, you could start by subtracting 51 and 34 since it's an improper fraction and get 1 over 1 and 17 over 34. Or you can just go ahead and do the other methods, the prime factorization methods, where you can do 17 over 3 and 34 is divisible by 2, and that would be 17 and 2. And then the 3 on top and the 2 on top cancel out, or the 17 cancel out, and that leaves a 3 and a 2.
So, again, I said this earlier, but please do not have an argument in the chat. You know, you just don't. Yeah. Okay. We are going to do one more practice problem. Yeah, we will be doing one more practice problem just so you all are able to get it, and then we will move on to exponents. So what is 35 over 56 when we simplify?
Who do we send it to?
Send it to me for this one. Okay, I'm just gonna write like whoever you should send it to in the top. And again, remember, please private message. Okay. Okay, yeah, I'm seeing a lot of correct answers. It is 5/8, so what we could do is 35 is obviously divisible by 5 since it ends in a 5. And then that means when we divide it out, we get 7. 56, we can see that it is divisible by 7 also when we divide it, and we get 8 as the other factor, right? So that means that we can cancel out the 7s, and we are left with 5 over 8 as our answer. So yeah. Okay.
So we can also do some operations with fractions. First, we have adding and subtracting. And so for these, you have to make sure the denominators are the same. And then you can just add or subtract across like the examples show, where 1 over 5 plus 2 over 5 equals 3 over 5, because the 5s are the same, so you don't have to do anything to them. And then you can just add 1 plus 2. And then the bottom example shows 5 over 7 minus 2 over 7. And again, since the 7s are the same, you don't have to do anything to the numbers. And you can just subtract 5 minus 2 to get 3. And so the answer would be 3 over 7. But
Okay.
sometimes the denominators are not the same. And so for this one, you have to make it the same by finding a common denominator. And so one way you can do this is by multiplying each side by the opposing denominator. So you can multiply 1 over 3 by 4 over 4 to get 4 over 12. And then you can multiply 1 over 4 by 3 over 3 to get 3 over 12. And so basically with this method, what you're doing is, since 4 over 4 is technically 1, when you multiply a fraction by 4 over 4, you're just multiplying by 1. And so you're not actually changing the value, you're just changing how the number is perceived. And so now that the denominators are the same, you can add across, so that will be 4 plus 7, and the answer will be 7 over 12.
So remember that all we're doing is adding the numbers on the top, which is the numerator. We aren't actually adding anything to the denominator. All we have to do is make sure that they are like the same. So like if you have trouble understanding why, like think about if you had a pizza, for example, that was divided into like 8 or 4 parts, okay? Because 8 would be too long to draw. Right? So say we have a pizza that looks like this, right? And we had someone who took 1/4 and someone who took 1/2, right? We aren't 1/2 is equal to 2/4 of the pizza, right? We aren't changing the, like, if we were to add 1/2 and 1/4, we don't magically get 6 total pieces, right? Right, it's not equal to 2 over 6 or something, which would be 1/3, right? It's equal to adding those pieces, but making sure that the total number of parts is equal, right? So yeah, so because the denominator is the number of parts we're dividing the whole into, it doesn't actually add up. We're only adding the numerator, so that makes sense. Okay. Yeah, and then we have multiplication. For multiplication, we do just multiply directly across, right? So we multiply 2 and 5, and we multiply 3 and 6, right? 2 times 5 is equal to 10. 3 times 6 is equal to 18. So that would mean we would get 10 over 18. We can simplify this using what we learned earlier to get 5 over 9. So we don't really have to have the same denominator when multiplying fractions. We just need to have two different fractions, really. Or like they don't even have to be different fractions, they just have to be 2 fractions, right? And then division is exactly like multiplication, except it isn't, right? So what we do is we keep okay, wait, Freddie, your hand is raised.
For subtracting fractions, do we also need to have the same denominator? Or just
Yes,
addition?
yes. For both subtraction and addition, we need to have the same denominator. But for any other operation like division or multiplication, we do not. So yeah. And it's, if you already know this, that is good, right? If your teacher taught it to you, that is good. This is a review for you then. But yeah. So what we do is for division, we keep the first one the same, right? We keep this fraction the same. Then we change the sign, right? So we change it into multiplication. And then we flip the last fraction, right? Because if you think about it, like say for example, instead of 2/3, we were dividing by 2, right? That's equal to multiplying by 1/2, right? So that's what we are essentially doing. We are just multiplying it by a number that will get us the same answer. Yeah. So yeah. So what we will get when we multiply or divide these out, 3/4 divided by 2/3 is equal to 9/8, right? Because 3 times 3 is equal to 9, 4 times 2 is equal to 8. So yeah. Okay.
So the reciprocal of a number x is just 1 over x. And if you multiply a number by its reciprocal, you get 1. And so the reciprocal of a fraction, so 2 over 3, the reciprocal of 2 over 3 is just 3 over 4. Or, sorry, 3 over 2. And what you do is you just put the denominator in the numerator spot and put the numerator in the denominator spot.
Yeah, so it's basically we're flipping the fraction, right? So 2 over 3 is equal to 3 over 2. So if we think about division of fractions, it's equal like doing like one fraction divided by another is equal to multiplying it by that second fraction's reciprocal. So yeah. Okay, you do not get it. What specifically do you not get? You can unmute if you. Okay. Okay. Just remember, I can't help you, or we can't help you if you don't tell us what your question is, right? Because then we can't answer. So if you do have something you're confused about, then just tell us what specifically it is. Okay. So okay. Okay. So there are two things people don't understand. So it's what exactly a reciprocal is and how how to keep changing flip. Okay, so first I'm gonna go over what a reciprocal is, right? So a reciprocal would just be if we're dividing one by a fraction, right? So that would mean if we were to divide a whole into by 2/3, right? What would we get? So uh, so if okay, I'm trying to think of a good way for you to visualize it. I honestly can't, but basically it's where we're flipping the numerator and denominator of a fraction, and it's helpful especially when you get on into higher math, but it also is applicable to when we're dividing, right? Because a reciprocal is basically going to undo any operation that it's basically the exact opposite of a fraction, right? Its reciprocal is the exact opposite since we're swapping the numerator and denominator, right? So let's think about it in terms of division. So when we're dividing by 2/3, that's equal to multiplying by 3/2. And that's what I mean when I say that it's like that a reciprocal is the exact opposite of a number, right? So if you think about it, right, dividing by so let's take a number that is that we could write as a fraction, right? 2 over 1, which is equal to 2, right? If we were to divide 3/4 by 2 over 1, right, which would just be equal to dividing by 2, then that's equal to multiplying by 1/2. So okay, so it's equal to multiplying by 1/2. And if you think about it, right, that makes sense, right? Because when we divide by 2, we're just finding half of a number, right? So so that's what so that's what I mean when I say reciprocal is basically undoing an operation, or it's the opposite of a fraction, right? We can use it to undo yeah, so if we were to do divide by 2 over 1 and then multiply that, or divide by, okay, so if we were to divide by 2 and then divide by 1/2, that's equal to no change, because dividing by 2 is equal to dividing by 2 dividing by 2 and then dividing by 1/2 is equal to finding half and then doubling that, right? So that's basically what I mean when I say that a reciprocal would be doing the opposite. And what keep, change, and flip means is we keep our first fraction the same, right? So we have 3 over 4, right? So we keep this the same. And then we change the sign and the, okay, we change the sign here to multiplication, right? So we can see here we are changing it. And then we flip or find the reciprocal of 2/3, right? So the reciprocal of 2/3 is 3/2. So that's what we mean by keep change. Does that answer your question?
Yeah,
Yeah.
thank you.
You're welcome. Okay. So we are going to okay, actually we're gonna do a bluket, right? Because this will review fractions for you, but it's also pretty fun, right? So I am going to host a bluket. So if you have not used bluket before, I'm going to type a link in the chat. I want you all to go to it and then type in whatever the code is, right? So is there anyone you prefer? If any of you have played this?
Gold Quest.
Gold Quest.
Gold Quest.
Gold Quest is goaded.
Okay.
Gold Quest.
Okay, next time, to the people in the chat saying Dino, we will do Dino. Okay. But this time we're doing Gold Quest. So we have 12 minutes. I'm just gonna say 10.
Where's the link to the thing?
Yeah, where's the link?
He
give
hasn't
me,
started
yeah.
it.
Like, plus now. Okay, so go to play.bluget.
Are you gonna send us a link?
Yeah, so okay, and then you're gonna type in this code on whatever it says. Please try to use like your real name or a nickname, right? Just so I know or just so we know who's there. If you want, you can use your phone and just scan the QR code here.
Where's the link?
I typed play.bluget.com in the chat. I don't think it will show it as a link, but just copy paste it from the chat. Yeah. So I know there are 26 of you right now. There are only six of you in the bluket. So please tell me if you have any technical issues. So we can get started. So I see 14 of you here. I'll give you all another minute and just make it started. So there are 26 of you who are supposed to be here. There are 24 right now. I'm just gonna go ahead and start it. Okay. you should still be able to join. Okay, basically, you